Okay, now, we could also write this okay. So you have a single matrix that takes you from B to B prime. And of course, the inverse of this matrix would take you from B prime, basis B prime to basis B. Okay, so okay. You just take the B prime matrix, augment it by the B matrix, reduce the B prime matrix to the identity, and you're going to get the P matrix. Easy to understand why, because if you do well, obviously, this is how you get the inverse of the matrix. Okay? So if you reduce B prime to I, it'll take I to B prime inverse. Well, I'll let you ponder a little while, but it's pretty clear why. If you start with B instead of the inverse, think about the elementary matrices and how they work on it and everything. It's pretty obvious that what you're doing is you're multiplying B by the elementary matrices that multiply out to B prime inverse. So that what you get down here is B prime inverse times B, okay? So you just think what would the elementary matrices do and where they would be in the process. It becomes clear why this works. So, and I'm going to let you think about that because I think it can become clear to you in a way that's going to be more beneficial to you than if I break it down. Okay, I mean, I could write out all the elementary matrices and do that yourself. So do that. Okay? So anyhow, what this is then okay. Okay, well, you know how to do the reduction. I don't think I have to tell you anything. You can take 10 seconds and look at an example and you'll understand it. Okay? I believe. And if I'm wrong, tell me.
Okay.
Okay? If I'm thinking you can make a jump that you can't, or that is harder for you than I say it's going to be, let me know, because then I have to know how far to jump to. Okay? Give me a goal to be a mathematician. Realistic goal. Okay? Learn to fill things in as I've seen you do again and again. Okay. So in saying that, I forgot what I was going to say next. Oh yeah. Super neat thing about this that we won't get to for a while is if this basis happens to consist of eigenvectors, okay, then the representation in terms of that basis is it's a diagonal matrix with the eigenvalues, so that this P matrix diagonalizes. Okay? Oh, pretty neat. And then that leads to some really deep stuff. Okay? And then we'll only scratch the surface of it. I mean, goes way deeper than I can go. Go just a little further. Because this wasn't my field. I just did the usual graduate stuff, the PhD qualifier stuff, and beyond that, I've never had the need to use it, although I find it really interesting. If I had time, I would. Of course, now at my age, I don't know if that would do any good, but I could. Anyhow, okay. So maybe I'll even make that. You have to go what's called a similarity transformation. You got a P inverse and a P, and you got to start with your standard basis representation and do like a P inverse A P type thing. Okay, and we got to talk about what that means. We got to develop more machinery and linear transformations and stuff. Do that. But anyhow, this leads to diagonal matrix. The eigenvalues in the diagonal. Okay? Okay. So, this is very important stuff.